Good morning. My name is Aradhya Tripathi, and today we will be discussing about the virtual power plants and the distributed energy management systems. So these are the contents of which we will be discussing the topics, the basic working principle of VPPs and the key components, how energy is managed and distributed, the challenges and the limitations, the recent advancement in the past few years, the real-world examples, and the future of VPPs. Now, the very first question arises is what is a virtual power plant? A virtual power plant is a network of decentralized energy resources such as solar panels, wind turbines, and batteries to store that energy, all of which are connected through a digital network to operate as a single flexible power plant. Now, the question arises, why do we need such kind of energy management system which is distributed? We already had the centralized energy system which was consisting of the traditional centralized power grids, but they were struggling to handle the variable renewable energy. The rising electricity demand, the grid congestion call for flexible energy systems. These localized energy generation from homes and industrial needs smarter coordination. The- And here comes the virtual power plant. The virtual power plant connects the distributed sources into one flexible coordinated network. This helps in improving the reliability and cut the cost and reduce the dependency on the fossil fuels. Now we'll discuss about the basic working principle of the PPP. As we can see from the image, there are multiple energy sources such as solar, wind, and the battery to store that energy. And all of these are connected to a VPP platform, or we can say the brain of the virtual power plant via smart IoT devices. And the brain of the virtual power plant is integrated with the grid. Then these local energy sources like solar panels and wind turbines generate the power. Each source is connected to a smart controller or IoT device. Then the control system monitors the generation, demand, and storage levels. It decides when to store, when to supply, and when to trade that energy. Operators can manage everything remotely through software dashboards. That's the main advantage of virtual power plants. There are some key components such as renewable sources such as solar, wind, hydro, and the storage will be required. So the batteries and the brain, which is the control system, so we'll require some energy management system and communication network like technology like 5G, fiber, and IoT devices for real-time data and secure bidirectional data flow. Now we'll come to how energy is managed and distributed. First, the resource aggregation comes in. Thousands of small distributed energy assets like solar batteries, EV chargers are networked together digitally. Then there is a centralized intelligence, which is a cloud-based platform, monitors real-time data and forecasts grid needs. Then this brain of the VPP takes the decision via algorithms. Then the grid service provision. The aggregated energy is distributed to the main grid to provide stabilization service like peak shaving and frequency distribution. There are several benefits of the virtual power plants. First being the efficiency, that the improved energy utilization. Second being the sustainability. VPP promotes the use of renewable energy resources and resilience. Challenges and limitations. There are several challenges and limitations as there were older regulatory and market barriers which act as an obstacle for the virtual power plants. Then there is the risk of data stealing, cybersecurity, and data latency, and the accurately prediction of the output of the renewable energy resources is very much difficult, and the customer behavior in real time is crucial, but inherent weather variability creates operational uncertainty. So it is very hard to accurately predict the production of the energy. The recent advances we can talk about are vehicle to grid integration, in which the energy flows between the vehicle to grid and grid to vehicle. There is a AC-DC bidirectional EV charger, as you can see in the image, in which the energy is flowing through the car to the residential home, through which it is going to the grid, and from the home it is coming to the charger, which can charge the vehicle back. There are some cross technology aggregation, the data center and industrial load participation, etc. Now comes the real world example. In this image, we have shown the Tesla interface in Australia, in which they have installed the virtual power plant and they have aggregated the solar panels from different residential houses. And this is the interface from that one user, in which he or she, the owner of the residential house, can see how much energy they have generated and how much they will pay and how much they will get, all of the insights about the virtual power plant. And in India, there are also government initiatives focused on modernizing the advancement in this area. The We'll talk about the future of VPPs. A VPP will play a major role in building the smart cities, because the smart city will require as much renewable energy and integration and improvement in urban energy systems. Then they will also help in green transition, that is, they will help in reducing the dependency on the fossil fuel, as they are only backed up by the renewable energy systems. Now we'll come to the summary and conclusion. So, digital power plant, a VPP, aggregates thousands of small distributed energy assets using a centralized cloud-based platform. There's a two-way balancing, effectively manages energy flow, injecting power when the grid needs support, and absorbing energy when supply is high, ensuring stability. And the future grid enabler. VPPs allow for the massive integration of intermediate renewable energy, making the power system cleaner, more resilient, and highly optimized. These are some references and resources from where I have collected this information. Thank you.